Hi, grade 12s. Welcome to my YouTube channel. And I hope that you are getting ready day by day as you prepare for the upcoming final examinations. In this video, I'll be doing a questions on acid and bases. So what I basically did on this video is that I introduced the RICE table for stoichiometric calculations that will make these acid and bases calculation more simpler to interpret and understand. So we'll start with 7.2.1, which is a navigation question, or it's a question that guides us on the initial things that we must get before we can answer the main question, which is 7.2.2. So let's get down to it. So we're being told that a sulfuric acid solution is prepared by dissolving 7.35 grams of H2SO4 in 500 centimeter cubes of water. And then the first question requires us to calculate the number of moles of H2SO4 present in this solution. So when we are asked to calculate the number of moles in stoichiometric calculations, we must make sure that we check the given information. So from the given information, we realize that we are given the mass of the sulfuric acid. And if we're given the mass of the sulfuric acid, to calculate the number of moles of sulfuric acid, we're going to use the formula that involves the mass. And the mass of sulfuric acid for 7.2.1 will be calculated by mass over the molar mass. The number of moles of sulfuric acid will be the mass over the molar mass. And this formula, we chose it because of the information that we're given. We took advantage of the fact that we're given the mass. So we're going to use this particular formula to get the number of moles. So whether it is a mass, we're going to substitute 7.35. And then the molar mass of sulfuric acid will be 98. So we're going to have 7.35 divided by 98. That is going to give us 0.075 mole. So these are the number of moles present in the solution for H2SO4. And then now we're going to the main question. And the main question is the one that I said I'm going to introduce a RICE table. A lot of you will know of the RICE-E table, which is the chemical equilibrium constant table, the KC table, the RICE-E. So for acid and bases, I will introduce what we call the RICE table. The RICE table makes this question to be simple to interpret and to understand. So let's check what's happening here. They're saying that sodium hydroxide pellets are added to the 500 centimeter cubes H2SO4 solution. The balanced equation for the reaction is this one that we have. So we realize that the sodium hydroxide that was added was in solid state. So if the sodium is in solid state, it means that it carries a zero volume. So it does not change the volume of the solution. So every time when you add a solid, you must know that the volume of the solution is not affected by the solid. So it means that the volume of the solution will still be 500 centimeter cubes because the sodium hydroxide is a solid. So it carries a zero volume. And then after completion, the reaction, after the completion of the reaction, the pH of the solution was found to be 1,3. Then assume complete ionization of H2SO4. And why do we have to assume this complete ionization of H2SO4? Grade 12s, you don't have to forget that H2SO4 is a complete, it's a strong acid. And a strong acid by definition ionizes completely to produce a high concentration of hydronium. So let us get to 7.2.2. Calculate the mass of NaOH added to the H2SO4 solution. So we want to calculate the mass of NaOH that was added to the solution. Assume that the volume of the solution does not change. They're saying we need to assume that as the reaction progresses, the volume of the solution does not change. So when we do the rise table, we need to locate the NaOH that is needed there. So let's quickly start with our rise table. So it's 7.2.2. We're going to have R, I, C, E. That is rise. R is for ratio. N is for initial. C is for change. And E is for end. So it's not for equilibrium. And the reason why it is not for equilibrium is because here we're not dealing with equilibrium. So that's the end of reaction. So that is initial in moles. So you must make it a point that you indicate the units of the initial quantity there. And then the change also, we're going to deal with moles, the end in moles. So if maybe you're dealing with concentrations, you will indicate that that is initial concentration in mole per dm cubed, a change in mole per dm cubed, just like that. So here, we're going to include the reactants in the rise table. And the reason why we include the reactants is because these are the two substances that have information. So we don't have to follow equilibrium rules there. You remember in equilibrium, we don't include substances in solid state, but here, because we are dealing with acid and bases, we can include anything in any state as long as we've got information given of that particular substance. So we're going to include it. So here we're going to include both the reactants. So if we include both the reactants, we're going to have two columns. This is our rise table. And here will be, the first column will be for H2SO4, that is the sulfuric acid. And the second column will be for NaOH, which is sodium hydroxide. And now we need to fill in the ratio. The ratio, therefore, sulfuric acid is 1, for NaOH is 2. And then let us check from what we're given here. We're given the pH of the solution. It was found to be 1,3. We're 12. You must always remember this, that the pH of a solution is determined by the reactant that is in excess. pH of the solution is determined by the reactant that is in excess. So always pH is determined by the excess. So this 1,3, the pH of 1,3 is for the excess reactant. So this pH will tell us which reactant was in excess. The pH of 1,3 indicates that the solution is acidic because it is less than 7. So if the pH if the solution is acidic, it means that the acid was in excess. So H2SO4 is the excess reagent, and this one becomes the limiting reactant. And where do we get this from? We get it from the pH of 1,3. The pH of 1,3 indicates that the solution is acidic, and if the solution is acidic, it means that the acid is in excess. Okay, so if the acid is in excess, NaOH is limiting. Does it mean? What is it that we need to conclude of NaOH? It means that NaOH reacted completely. It was used up completely. So at the end of the reaction, the number of moles of NaOH was 0 because all of it was used up. It is a limiting reactant. Why is it a limiting reactant? It is a limiting reactant because the acid is the excess reactant. Okay, and then let us check now. What is it that we can calculate from the pH given? When we're given the pH, we're going to get the concentration of hydronium, because if we're given the pH, then we're going to use the pH formula to calculate the concentration of hydronium. So the concentration of hydronium, we're going to substitute the value of pH there, which is 1,3, equals to minus log the concentration of hydronium. Therefore, the concentration of hydronium will be given by 10 to the power negative pH. And then this will be equal to 10 to the power negative 1,3. So 10 to the power negative 1,3 will be the concentration of hydronium. And the answer for the concentration of hydronium is 0,05012 mole per dm cubed. So this is the concentration of hydronium. So since I indicated that the pH is determined by the excess, so the concentration of hydronium that we have, this is the concentration of hydronium in excess. And why is it excess? It is excess because we got it from the pH. But now in the rice table, we don't have hydronium. What we have in the rice table, we've got sulfuric acid. So we need to use this concentration of hydronium to get the concentration of sulfuric acid. So how do we get the concentration of sulfuric acid? When an acid and a base react, and this reaction takes place in a container where there is water, there is a reaction that takes place in the background. Learners, please don't forget this reaction. This reaction takes place in the background. It is always there, but not indicated. That is the ionization of the acid. What we know, learners, is that sulfuric acid, when it reacts with water, because sulfuric acid is a strong acid, it's going to ionize almost completely to produce 2 hydroniums and SO4 2 minus. This is the reaction of complete ionization of sulfuric acid. So this reaction takes place in the background. It's there. Why does it take place? It's because sulfuric acid will react with water, and when it reacts with water, it's going to ionize. And this is what we're going to have. So this is the reaction that allows us to relate sulfuric acid and hydronium. So you cannot relate sulfuric acid and hydronium without this equation. So what we have here is that we have the concentration of hydronium. And when we have the concentration of hydronium, we are trying to get the concentration of sulfuric acid. So the concentration of hydronium that we have there, it's 0,05012 mole per dm cubed. But in our rice table, we have got H2SO4. How do we get the H2SO4? We're going to use the ratio of the ionization equation. What is the ratio? It's 1:2. So therefore, the concentration of sulfuric acid, because of the ratio there that we have above, is half the concentration of hydronium, because of the ratio of 1:2. And then this one will give us 450 divided by 2. This is going to give us 0,2 2506 mole per dm cubed. So this is the concentration of sulfuric acid. And when we have the concentration of sulfuric acid, we are going to get the number of moles of sulfuric acid. And how do we get the number of moles of sulfuric acid? It's because we know the volume. What is the volume? The volume is 500 centimeter cubes there. And you need to understand why I'm getting the number of moles. I'm getting the number of moles because remember we're trying to complete the rise table there. So in the rise table that we have here, we don't have concentration, we only have moles. That is why I have to convert this to the number of moles. So the number of moles of sulfuric acid will be given by C times V. The concentration is 0,2506. And then the volume is 500 centimeter cubes. 500 centimeter cubes must be divided by 1,000. And we convert it to decimeter cubes. So it means that the 500 centimeter cubes as volume there will be substituted as 0,5. So we multiply it by 0,5. This will give us 0,01253 moles. So this is the number of moles of sulfuric acid in excess. And why I'm saying it's excess is because we got these number of moles using the concentration in excess. So this is the number of moles of sulfuric acid that was in excess. So we go to the rise table, we substitute the value of the number of moles of sulfuric acid. So it's 0,01253. Okay, what else do we know of sulfuric acid? We know the initial number of moles of sulfuric acid. And the initial number of moles of sulfuric acid, these are the number of moles that we calculated in 7.2.1. This is what we started with. And we have excess. What do we have after completion? So the initial number of moles of sulfuric acid is 0,075. So if this is the initial number of moles of sulfuric acid, what is it that we're going to get here? We're going to get the change. We started with 0,075, and then at the end, we had 0,1253. So how do we get the change there? The change, we subtract these two values. So when we subtract 0,01253 from 0,075, what are we getting there? So the change will be, it will be 0,06247. That is the change. And then remember, the change row is the only row where we can use the ratio. So if we can have one box, we can get all the other boxes using ratio. What is the ratio? 1:2. So if this side is 0,06247, the other side, we're going to multiply it by 2 because of the ratio. Then therefore, we're going to have 0,12494, which is a minus. And then let us go to the question. Let us check what they're looking for. In the question, they want us to calculate the mass of NaOH added to the solution. So they are basically looking for the initial mass of NaOH. So if they are looking for the initial mass of NaOH, it means that we must first get the initial number of moles, which is this box here. So if we can get the initial number of moles, it's going to be simple for us to get the initial mass. So with the information that we have already, we can calculate the initial number of moles of NaOH. So if this is the change and what we have is 0 at the end, so we need to understand what did we have initially if we used 0.12494, and then we end up with a 0. So it means that we had 0.12494. This is the limiting reactant, right? So this is the initial number of moles of NaOH. So if we have got the initial number of moles of NaOH, the initial mass of NaOH can simply be calculated by, so therefore we're going to say the mass, that's the final answer. The mass of NaOH added will be given by number of moles times the molar mass. So the number of moles is 0.12494. It's 0, I missed that value. It's 0.124, 0.12494. We multiply it by the molar mass of sodium hydroxide. So it's 23 plus 16 plus a 1. That will give us a 40. So we've got 40 times that, times 0.12494. Then this one will give us a mass of 4.9976 grams. That is equivalent to 5 grams. So this is one of the best and amazing methods that you can use for acid and basis calculations. A lot of learners, they struggle with interpreting these written statements in the memorandums, but when you can take everything to the rice table, this is simple for learners to understand. Please watch this video, go through it again and again up until you understand what's happening, and tell me what you think about it in the comment section. Don't forget to like it, subscribe, and share.